11.3, now we're using geometric properties of the cross product. So let u and v be non-zero vectors in space, and let theta be the angle between u and v. So we're going to, u times v is orthogonal to both u and v. The magnitude of u times v is magnitude of u times magnitude of v times the sine of theta. U times v equals 0 if and only if u and v are scalar multiples of each other. And then the magnitude of u times v is equal to the area of parallelogram that has u and v as adjacent sides. Both u times v and v times u are perpendicular to the plane determined by u and v. One way to remember the orientations of the vector u, v, and u times v is to compare them with the unit vectors I, j, and k. And then k equals I times j. So notice it here. So here's I, here's j, and k is I times j. The three vectors u, v, and u times v form a right-handed system. So notice we're in this plane here. So example 2, we're going to use the cross product. Find a unit vector that is orthogonal to both u equals 3i minus 4j plus k and v equals negative 3i plus 6j. So first we need to find the cross product of u times v. So when we do that, we write I, j, and k, so what we did earlier, and then u, so we're finding u times v. And then, so that is 3, negative 4, 1. And then v is, I is negative 3. And j is 6. And k is 0. Then we're going to use the determinant. So I, 3, 3. J, negative 4, and 6. And then we multiply and add these together. So this is going to be 0, and then plus 3j plus 18k. Then we're going to subtract, going the other direction here. And so this is going to be minus 12k, because negative times negative is positive, but we're subtracting. 6 times 1 is 6, so that'll be a negative 6i. Then 0 times 3 times j, so that's minus 0 here. So then we will have, so let's write it in the correct order. So I is first, so we just have a minus 6i. And then j, we have a plus 3j. And k, negative 12 plus 18, that is a plus 6k. And so this is orthogonal to u and v. Now, number 2, we're going to find the unit vector. So unit vector, we are using u times v over the magnitude of u times v. So we already found the u times v. That is what we did first. Okay, so I can label this as u times v. This is what this is here. And then the magnitude of u times v. So let's write this here. Negative 6i plus 3j plus 6k all over. Now to find the magnitude, it's a square root of this squared plus this squared plus this squared. So this is going to be negative 6 squared plus 3 squared plus 6 squared. And so this is going to simplify. So negative 6i plus 3j plus 6k all over the square root of 36 plus 9 plus 36. So negative 6i plus 3j plus 6k. So that is all over the square root of 81. Then the square root of 81 is going to be 9. So all over 9. And so we need to break this all apart, simplify it. So we have negative 6i over 9. That is going to be negative 2/3 I plus 3j over 9 is j over 3. And then 6k over 9 is going to be 2 over 3k. So try this on your own. Find a unit vector that is orthogonal to both u and v given here. And so remember, first you have to find u times v because that is what's going to be in the numerator here. Then you put that over the magnitude of u times v and then simplify if you can. So if you try this out, u times v, you would get negative I plus 2j plus 2k. Then the magnitude of u times v, that will just be 3, so that's in the denominator, and then you split it apart. So you get negative 1/3 I plus 2/3 j plus 2/3 k.